Hi, everyone. I'm Rebecca Wright, Director of Computer Science at Barnard. Welcome to our Computer Science seminar. I'm happy to have with us today Professor Jean Camp, who is Professor of Informatics and Computer Science at Indiana University. Her research focuses on the intersection of human and technical trust with the goal of building for end-to-end empowerment. Jean began her career as an engineer at Catawba Nuclear Station after a double major in electrical engineering and mathematics, followed by an MSc in optoelectronics at the University of North Carolina at Charlotte. She went on later to earn a doctorate at Carnegie Mellon and spent the year after that as a senior member of the technical staff at Sandia National Laboratories, and also spent 8 years at Harvard's Kennedy School of Government, where her courses were also listed in Harvard Law, Harvard Business, and the Engineering Systems Division of MIT. Jean has been widely recognized for her research, including as a fellow of the ACM, a fellow of the IEEE, a fellow of the AAAS, and as a member of Sigma Chi, the National Research Honor Society. We are delighted to have her here with us today. Jean, the floor is yours.
Thank you. So I am going to talk to you about how even the most theoretical components of the network are really quite interdisciplinary. And before I do that, I will introduce myself. My topic today is fundamentally trust. How is it governed, by whom, and who is at risk when trust fails? Spoiler, everybody. So I kind of study all 9 layers, which means, you know, I started at the nuclear plant, so I can say I started at the plug and I go all the way to the person, because you don't have much of a physical layer if you don't have power. And so I want to talk to you about the original PKI design goals, and then talk to you about how these are playing out today, both in individual homes, in individual browsing, and from a geopolitical perspective at the edge of the network, in the core of the network, and central to what is happening in the world. I was a professor of public policy at Harvard for many years. I came to Indiana University. I taught their first security class. I was a professor of informatics. Then I was a professor of informatics and computing. Then I was a professor of informatics and of computer science, which is what I am now. And I never changed offices, which is, I have had other professorships. I have some traditional honors, right? I've written hundreds of peer-produced papers. I've given presentations in the National Press Club, the White House, RSA, Black Hat, NSA, and I am very proud to be a fellow of the IEEE and the AAAS. I am the only person I know of who has both been a visiting professor of philosophy at Erasmus University in Rotterdam and a visiting scientist in the laboratory for computer science. I was on the Hill in 2010. I applied in 2009 to show you that I am definitely not always right. I applied in 2009 and I thought certainly healthcare will be over by then. When Obamacare was voted in August of 2010. I was in the gallery. And then I was a visiting researcher for long-term cybersecurity in 2019, which is a joint between Berkeley, EECS, and law. So I've had some less traditional honors. Rebecca and I, when we were co-chairs a long time ago, we had paid the first caregiver travel scholarship. We were given a budget as chairs, and we said, if you need to bring a caregiver so you can attend, here's your caregiver scholarship. In one presentation, Sanchari Das and I were 25% of the diversity in Black Hat presenters. Which hey, that's pretty good. We had some early issues about voting, actual technical issues about voting that was distributed to the Democratic Convention. And I have always been proud to be a champion of diversity, which has not always been effortless. So I want to talk to you about trust. Who can change your computer? Who can change your network settings? Who can change the infrastructure? Who can change your implants? We talk a lot about traditional vulnerabilities. Your code is not secure. I can break into your code. I can subvert your code. But if your code is not subverted and everything is working perfectly, who can change it? Why you trust them, and how does that work? And why does it matter? So here's a question. How were the Russian network attackers able to convince the Ukrainians to install software from an unknown, unfamiliar Russian company as they were being invaded? How did they do that? Well, they had a legitimate certificate. Look, you know, Hermetica Digital, it's totally valid. DigiCert, it's a code signing certificate, right? Perfectly acceptable code signing certificate signed by Microsoft. It allows you, approved by Microsoft. It went all the way up the chain. So that is, those are the fields from their certificates. DigiCert isn't provided to do this. So that entity can be trusted to install code. The update is exactly what we meant to send. Yes, they meant to send malware that wiped their computers. It had integrity. The integrity checks were correct. It was sent from the people who said they were sending it. Yes, we are a Russian-owned company and we are sending this code and it's doing what we said. And the communications with, the key exchange worked. Everything was perfect. The cryptography was great. Yay. Awesome crypto. I went the wrong way. So who decides this? Actually, there are very few people who decide who you trust. There is a hierarchical system, and this is particularly focused on the web right now, of root program operators, of whom Google is the giant. Mozilla has mostly now uses Google's. Apple has their own key infrastructure, particularly for their code, but for web signing, you can still have a Safari list, which comes from the operating system. The Microsoft browser list traditionally has come from the operating system list, and Tor, which uses Mozilla, which uses Google. So there's really very few people on the planet deciding the processes for who you trust. Root program operators select root certificate authorities and set policies. The certificate authority browser forum is the governance entity that has root program operators. Root program operators sign root keys sign certificates. And they set their own policies, which need to align with the root program operators. The root program operators policies are quite similar, and the CAs issue certificates and you trust them. And that's just like you trust going over I trust an infrastructure when you drink a glass of water. So one of the things I wanted to do first is, this is great, it's fine, we trust these people. What do we think we're trusting them to do? If you are trusting a person, it is absolutely right for you to be able to make incorrect decisions. We've all made bad trust decisions. Just think about the last time you talked to an airline. So we wanted to determine what people think is going on. Because if there are systematic failures, but individuals know there are systematic failures, then arguably there's no problem at all, because individuals are empowered and they're making their own decisions. But if they're not, what are the failure modes and what are the failure patterns? And we also observe widely used certificates and talk about how we need different types, and not just different technical types of solution, but different domains to engage in solutions. So to discover the perceptions of PKI, we did a survey. We went to the farmers market, we went to MTurk, we went to fandom conventions. We went to Gen Con. Okay, those are all nerd places except for the farmer's market, but we also went to the mall. And we went to 2 major conferences. So we asked people, just random internet people, what's a certificate? And they were very optimistic. This site has legal accountability, was popular. They really believe that if you get a certificate, it's from your jurisdiction and you have consumer rights. It has good privacy policies. Be still my beating heart. It has antivirus and is safe for hackers. One of the top answers was, happily, I don't know. Non-expert participants particularly focused on privacy and legal accountability. They have no concept of what are the limits. And so then we went to experts and we interviewed experts at TPRC, which is the Telecommunications Policy Research Conference. And it is so established that it is literally called telecommunications. That's how established it is. And we went to real world crypto. So real world crypto is mostly industry people who are talking about the difficulties they have and the reality of crypto. At the latest real world crypto, somebody illustrated, for example, an attack on Proto, which is the EU selected post-quantum standard. And they also hosted me one year when I talked about the rate of change in certificate updates. So they very broad, but so long as it's where the crypto rubber meets the network road. So the interview and workshop, solutions to PKI failures, everybody wants better code, more effective responses to rogue, more nuanced and fewer warnings was both parties wanted fewer warnings and also indicators about the warning and improved consumer protection and fewer roots. So fewer roots are easy. The big focus on rogues. Rogues are purposeful misissuances. This is a photo of one of the cards that was being sold by a healthcare provider. So it was an actual correct in every way vaccine card, except for it was totally false. It's no connection to reality. That's what a rogue certificate is. It's issued falsely and is knowingly issued. Like, you are Google. Others are issued but misused. A lot of recipient misrepresents their intentions, their identity, their authorization. Oh, you know, you're not Google, but you're G00GLE, right? That could be you. You could be Go. I can say that. And then there are not valid issue, but passable. They appear legitimate to the system. They're software problems. They're weak cryptography. Coming from Indiana University, we have a lot of appear IDs that are generated with an attempt to appear legitimate system. And so the things they disagreed on were the policymakers were like, those technologists, one of them literally said, those technologists need to be more careful. And one of the technologists literally said, those policy people need to do something. And by the way, exceptional access, also known as backdoors, was opposed by every person we interviewed across all the disciplines. So policymakers are looking for technical solutions because they're like, please fix this. Technologists are looking for policy solutions. Think, please fix this. So there's a need forward, but no clear path. So what is happening when we observe widely used certificates? We did 2 things. We have a data set from 2019 to 2022, and I've only done the qualitative coding through 2019 because qualitative coding is really labor-intensive. There were failures in 2010. Swart was particularly terrible. Startcom got hacked. Those of you who might remember, that was the first root CA hack. Is it still a problem? Well, people are like, oh, maybe it's less of a problem. Actually, if you look at the reported incidents in Bugzilla, starting in 2010, there are still multiple problems. WoSign is my particular favorite here because all of these were purposeful. SHA-1 was getting removed as an acceptable standard. There was a set date. WoSign responded by buying another company that was more widely trusted and then selling backdated certificates with SHA-1. So if you wanted really garbage crypto, you could still get it. Yay, the market. One of the interesting things is 71% of these are third-party reports. Most of these were not openly malicious, like WoSign, but they did not report it. This is 2019, which is how far I've gone through the coding. You can see that this is fairly chronic, that we have, very respected Swisscom and Belgium roots, very specialized sites that we might think would not be engaging in misissuance. So it's a chronic problem. Mostly it's non-compliant fields and certs, which you might think, oh, that's nothing, but a lot of them are certificate revocation problems. Like, here's your certificate, hope I never need to revoke it, have a nice 3 years. A lot of them said, oh, I just don't know. When you ask why there was an incident, software vulnerabilities, they're running bad vulnerable software in CAs. Human error means there was only one misissued. All of these are incidents, they're not certificates. So most of these have multiple misissuances. And my favorite is just the business model was not to check this. We're just going to sell these things. Oh, well, another fun one is we didn't know the law. I once tried that when I was speeding and it didn't work at all. They'll just bust you. So here we see there is concentration that does not correlate with market share. So SSL.com is large, but SwissSign is not that large. And Camafura is not that large. And also at the time, I believe they signed their .gov certificates. Microsoft is still in there, alas. On the other hand, this was 50% third-party reports. Companies are getting better about reporting when they misissue, and I personally think that that is a result of certificate transparency, that they know that they will eventually get noticed. So types of incidents, human error, you can see for 30 incidents, which is most likely to be reported by the CA. Believed to be compliant, unaware. Gosh, are we a CA? Did we have to do that thing? Here you can see their correlation is not causation. 2019 is when certificate transparency became default for every Chrome connection. So the problematic CAs are worldwide. This does correlate with market share. You can see that the US issues most of the certificates, but not entirely. Southern Europe does not dominate in certificate issuance the way it dominates in certificate errors. And this is just to show that there is a correlation. So fields not compliant. This includes both cryptographic strength and certificate revocation. So it might sound boring, non-compliant fields, but they're actually important fields, are the major source. So what do? It's not just rogues. People are vulnerable. They believe certificates do something that they don't, and literally cannot reject a certificate. Many people say there is no problem. Certificate transparency has solved it. We're going to address it. particularly reviewer 2 places. So some disagree that problems exist at all because they say it delivers the authentication of the identity of every user and device on the network. Where did I get this? This is literally a 2019 description of what PKI does by the Internet Society. And I appreciate their activism and their optimism. Data and system integrity I mean, honestly, if PKI did all this, we could just stop studying security. But we have this optimistic view. PKI is the foundation for zero trust. We don't need any other zero trust. My favorite thing is that is actually a DigiCert blog post. And DigiCert, you've seen their name before in this talk, right? So there is a problem. There's also a major consumer problem. I asked my class when this happened, I got about 60 undergrads, they're in security. I said, do any of you have NVIDIA? There's a certificate issuance. Do any of you have NVIDIA? One kid raises their hand. And then I was like, do any of you have Steam? And they all raised their hand. So there's not any kind of clear communication about when you're exposed to risk. So I'm going to argue that there is a problem, that rogues are not the only misissuance. We started a certificate observatory. I have about a terabyte of certificates. We weekly observe the top 1,000,000, which is not that many because we only observe changes. Like the daily top 100,000 almost never changes. And hourly, we look at fish tank, and we have a few volunteers using an extension and difficult to observe jurisdictions. So one of the things we looked at, extended validation, was going to solve this and make it really trustworthy. So the tick marks are January 1, you can see EV increased. And then in 2019, when transparency came in, it turns out all you did with an extended valid certificate, extended validation was supposed to be, I really know it's you. It is definitely you. But it turns out they were just charging more. So how do you find phishing certificates in a world of HTTPS? We took our fish tank set and looked at machine learning algorithms. We looked at different approaches, and we just use standard 10-fold cross validation. This is not data science research. This is bog standard research. And we looked at it. We had a partner group, and we looked at us, our partner banks, generally banks, major banks, which are the top 6 banks, which are qualitatively different in their quality of certificates. And then everything else. So we tried one classifier, right? 7 classes. We tried 6 2-category classifiers. Definitely IU, definitely not IU, definitely a bank, definitely not a bank. And that worked the best. And then we tried 6 versus rogue. That was not only the decision tree did very well, but if you consider the number of actual rogue certificates that you can access as an academic, you know, one of the things that we found that was of interest, and the reason I want to include this, is that when you look at mischaracterizations, this is a very typical way to compare it, like, oh, 96 is less than 99, so 96 is worse, right? But in fact, the types of characterizations that you have. So this is a legitimate mischaracterized as a phishing website. So each line is a certificate, right? Yes.
So you mentioned that it's harder to get rogue ones as an academic. What type of numbers are we talking about? Like what percentage of the ones that you observe are actually rogue?
Oh my goodness, rogues are very rare. We have like a few millions of certificates. I'd say maybe 4 million certificates, and tens of thousands of phishing and more like 100 rogues. So
Oh, I see. It's very, very rare.
yes, and then when the ones you can get tend to be associated with incidents. So this is the research that we publicly presented. The student that was doing that also interned in Microsoft for a semester and was able to access a richer, I mean, I'm glad they don't share.
Yeah.
It's like,
Yeah.
yay, don't give me this data.
Anyone.
But we were able to say that our results using the artificial data were representative of the results using that richer data set.
Nice.
So accuracy is not truth. If we think about it as accuracy, we also did a per CA using, I did not just pick these because I don't like them or something. These were that's consistently over the time period most likely to engage in misissuance, either in phishing certificates or in non-compliance certificates. So by focusing on a specific issuer, we were able to get higher results across the board. And also the problem with this approach though, is that you don't know who's going to issue the next rogue certificate. It works well for phishing, which is the major threat, but the rogue threat. And then how do you resolve this? So public key pinning, right? 2011, pin certificates for known domains. It absolutely positively 100% solves the problem for Google. Google's problem is solved. No one is going to use a Chrome browser certificate pinning and see Google be misrepresented. But it doesn't solve the problem for consumers, and it doesn't solve the phishing problem, because if Google has to pre-clear every certificate before it goes on the internet, that I cannot imagine their lawyers who are struggling with anti-competitive issues are going to approve that. So there's operator pinning, HTTP-based public key pinning that allows websites to assert key ownership. Only trust this. This is built into some IoT devices. It's kind of a weak substitute for self-authenticating addresses, but it's better than nothing. But on the other hand, it's no longer supported. It turns out, and this is the core problem in security, malicious websites will lie to you. And if you tell them they have to have a certificate, they will get a certificate and then they will still lie to you. Like if you look at the, Microsoft uses Certs, which does use some data analytics like the ones we were talking about. In fact, Microsoft will be proud to tell you that when my intern was there, the India CCA rogue certs were identified first by Certs. And then they, the other thing was the idea is DNSSEC for DNS authentication of named entities. It has CA constraints, right? Certificates issued under specific CA. You have to have service certificate constraints. So if you look at the famous use of malware to stop the Ukrainian centrifuges, are you guys familiar with that? The US and Israel created.
Ukrainian.
Am I saying Ukrainian?
Yes.
Oh, sorry, Iranian centrifuge. Sorry. That was a valid certificate, but it was a software licensing certificate. It wasn't a code signing certificate. And the one that had the certificate they used that had the hash collision, that was actually a licensing cert. So the service certificate constraints were more strictly enforced after the Iranian centrifuges started blowing up. And the trust anchor assertion used domain provided trust anchor to certify certificates for that domain. That is particularly important for things like transportation. The Europeans had a proposal in 2014 that said we will create our own trust anchors and only trust those trust anchors. But I'm going to argue that that's not a solution because, as you can see from the map, European CAs had the same business incentives and problems as everyone else did. And the other thing was to select a third-party pinning authority and send all your information to that third party. This is the kind of thing EFF would step up if it were mandated, but it created privacy issues. Our answer was to filter rogues and ban certificates to protect the end user regardless of what jurisdiction that certificate came from. We collected, huge numbers of certificates. We did a feature extractor. We had a rogue certificate simulator because we had so few rogues. And then we have a nice trained model for the rogue certificates, and then we put it in this thing. And we sent 8 households a whole IoT network. So this happened in late 2019. So we had to ship them a box. And I think I should probably do a paper on, we got 8 non-technical households to set up a secure network out of a box. Use a lot of pictures. And we run 2 models. So it turns out if you want to model the world, you need data about the world. If you want to model me, the best model for me is today is me yesterday. So we have the complicated model that we built using feature extractors. And we also just have a model that looks at whether or not you've been there before. So one of the things this did is we sent it with a highly constrained list of trusted routes. Even the most trusted routes misissue certificates. We could not require key usage or other extensions for validation, although it's a great idea because we're just researchers. What we did do is we had people look at browsing in their household and access to certificate authorities in the household and used a simple history indicator. The first time a certificate shows up, you should know it's a certificate. So here's a nice, that's my architectural overview. So here's one that people feel matters. Podesta is a guy who worked for the Democratic National Convention, and he was hacked and his email was released. If you guys remember, 2016 emails were really important. He got this email and then he saw this website. I got this from Pwn All Things. Thank you. Shout out to Pwn All Things. So you are looking at this and saying, hey, that is phishing because you are technically expert. And you know that Google's certificates are not issued from Tokelau. What Podesta knew was that Google was protecting him, including with certificate transparency. And it had the little lock, right? It was a well-trusted domain. And there it is in, I didn't know where this was either. So there's the big map. So if you just know that you're at a domain you've never visited from a top level country code, you have no history of interaction in, and it's signed it's a domain name like this, and then it's signed by a certificate authority at a country you might actually be a little hostile to, you can make an informed trust decision that he was not able to make. If PKI had met the promises of authentication that DigiCert had in its report that the Internet Society has offered, it would not have happened. But also if he had known that that promise was not being fulfilled. Right? We know if we're driving 80 miles an hour, we are at risk. And we make that choice anyway. But that is not a choice that, so we're building this now. That's one of our things. So here is my, I hope I have convinced you that crypto is an issue of law. It's an issue of usability. It's an issue of economics and governance. And it is fundamentally an issue of technology, because if you're going to have SHA-1 certificates, why have certificates at all, right? So I'm also going to conclude with this radical conclusion that a government system designed to protect credit card purchasers run by the certificate authority browser forum may not be optimal for the modern internet and may not be up for addressing major geopolitical conflicts. I'm feeling comfortable in that, but the end result is nuanced technical challenges that that are major data science challenges. How do you know when there's a tremendous amount of work both in certificates and domain names and content of web pages trying to catch fraud, masquerade, and theft pages. And I say approaching the intractable because there are many people who have come up with high 90 accuracy, but there's nothing that our adversaries have not been able to get around. So one reason it's intractable is, unlike modeling things like viruses, transportation, viruses or physical infrastructure, is that if your bridge wants to break, it's not going to move over to this other road, right? We don't have that problem, but adversaries are intelligent and responsive to all of our attacks. So, and here are some of my related papers. And I will absolutely share these slides with the hope that some of you are interested.
And we'll also, since you gave us permission, be posting the recording to the Barnard CS YouTube channel, so people can watch the talk that way as well.
Great.
Questions? And if you're on Zoom, if you unmute, we can hear you in the room, so feel free to ask your questions that way, or if you put questions in the chat, I can also repeat them for you.
No question. So you mentioned towards the end that you're doing some work to sort of address the problem of, a site that looks like Google, but if you read the URL, it's not. What are you doing in that space?
Oh, so we are doing two things. We are trying to look at the geographic hosting, because bulletproof hosting is one of the major issues that we see with malicious and phishing sites. And if you could isolate individuals that are not in that jurisdiction from those harms created by those sites, you would make a fundamental change, not just in empowering end users to choose to take risk or not, but you would change the macroeconomics of the problem. I mean, if you're a small nation and you are invested in bulletproof hosting and you are getting a lot of income from bulletproof hosting, and one of the things they're doing is not hurting people in your jurisdiction, then you have a strong incentive to keep doing it. But if you could say, all right, you can continue to host these, but they will only be able to access people in your region and your jurisdiction, that you are making the people who are making a policy decision are making a policy decision, not I'm going to receive income from that group of people over there. Right? But when the harm is generated in one location and experienced in another location. And part of that is trying to make certificates and that little lock mean what people think it means. If you really believe that, and many of our participants genuinely believe that the lock had jurisdictional meaning, and you are a person who primarily browses in your own jurisdiction, then you should know when you leave your jurisdiction.
So one of the reasons we have web PKI problems is the intended multiplicity of moved CAs. But that was the response to a desire for competition at the root level because having one is also bad. How do we resolve this? How do we square this circle?
Well, right now, the way we've squared that circle is by having basically 3 providers of certificate transparency and Certs. So I would argue that the goal of competition has not necessarily been met. That is not a challenge that I am struggling with in this paper. What I'm trying to do in this work is have people make an informed risk decision. And if you could be informed when you were leaving a jurisdiction, that could increase global competition. That could create a situation where, for example, people in East Africa, you suddenly have an incentive to go to your local CA as opposed that's with your domain name provider, because otherwise, when they hit your website, they're going to, a completely reasonable and trustworthy CA in France and a website that's hosted in the US. But if there's a marginal advantage, so this could be a complement to competitiveness. But I am actually focused on the US. I only speak English. I'm a product of America's proud tradition of monolingual public school. Okay, maybe not proud.
I'm curious if you have any sense of how many times when there is an invalid certificate, people just click proceed anyway. That's what I do.
Mostly proceed anyway, because the certificate warnings are all about syntax and tend to be semantically meaningless. The certificate warnings I get tend to be for self-signed certificates. You're going to Indiana. They did not give DigiCert $35. Are you okay with that? Right, that is the warning I encounter the most often, is self-assertions. And if you have an individual history, so if I went to IU and I'm sitting with IU and all my friends are at IU, then they all trust that root. Should I get that warning? And if we got fewer warnings, we would pay more attention to them.
So, but related to that, I mean, did you ask these users that you asked what they think these certificates do? Were you able to get any sense from them if you were to empower them to make these risk decisions and give them clearer warning, that explained what, wouldn't they still want to do? I think there's a lot of evidence that people who are trying to do something on the internet just want to do the thing they're trying to do, and it's very hard, even if you improve the sort of the scaffolding around it, to get them to pay attention to these questions.
So I would first like to say that I explicitly reject the proposal that security should be irritating. But clicking through a bunch of acknowledgements is irritating. And by making them visual, so no, I was saying we're just building this because we want it to be true when we build it. By making them visual and contextual, which is, you've never visited this before. This is where this website is hosted. This is where the domain is from, and this is who vouched for the website, right? To make you click through each of those things means 2 things. One, you're going to make at least a theoretically informed risk decision. 2, the reason you get it out of your way is because you've been trained that it's meaningless and you have to get it out of your way, right? Which means that you're literally engaging in what Slovic and Kahneman refer to as fast thinking, right? You've seen this a million times. But if you're looking at different maps and you're looking at different images to click through, we have an opportunity to get you to engage instead in slow thinking and a different mode of decision making. And also, if you look at vulnerable populations, computing expertise is having universal computing expertise is not an option. 15% of the American population is functionally illiterate. And, if you're looking at people clicking on links on their phone, some of them are 7. Maybe they'll be technically expertise, but if they're like 7, you need to give them a thing that they can understand. And this is on this island far away, and you've never met this person, and none of your friends have met this person. You can be 7 and understand that, but we don't test these on kids. I don't know enough about development and child psychology to click that box that says there is no risk in deception-based research on mobile devices for children.
Yeah, well, I don't know if there's one in the chat that's a follow-up on this, because I sort of had a separate question, so Rebecca,
Okay,
if there's one. that's a follow-up.
Mary, do you want to raise anything from your chat as a discussion point with Jean at this time?
I don't really want to raise a point. I'm as somebody who is using all of this technology online. I just find this very difficult, especially if you're not really knowledgeable about all of the security things that are going on. If you, for instance, ignore all your Google warnings and all of the privacy settings that are there, for me, on the bottom line, I don't really think that all of this should be sent to or the responsibility should be the user's responsibility. I think that there are other methods that should be like what you described today, that should be more implemented system-wide, instead of thinking that educating the user to be more knowledgeable is like a solution. Because I've read upon this, and apparently the education part of it wears off. Like, it's not something that sticks with the user, right? So there should be more onus on these companies, Microsoft, Google, whoever is providing these types of services, to have better systems in place.
I totally agree. I completely agree. I would also say, when I have this discussion with people and I've had these discussions at conferences, like the people who have known me know I won't always be the person who stands up and say, what about the 70-year-old whose entire retirement you're protecting? But I think recently I've started to point out, because that every year there's new 7-year-olds. So it's an intractable approach, right? So suppose you magically communicated the function of a public key certificate and the risk of accepting a certificate and how to parse a domain name to every 7-year-old in America, since a lot of them can't read, because again, 7, you still, next year you'd have entirely the same problem when, the kids get their phones as they go off to elementary school for the first time. Maybe that's a very American thing. I saw your face. So.
I had a different line of question. So when you sent that box out and you had, these non-technical folks actually install a secure network, and that worked for them.
Yay, yes.
Yeah. So let's say this is the solution, right? Like, how would you scale that?
Well, what you do is you would convince Comcast or AT&T that security can be an profitable, desirable. Economics of security tells you that once, and you don't have to tell Comcast or AT&T this, right? When somebody's network failed, they will, when you say my internet is down, how many of you have heard family or friends or like, and the first thing they do is they call their provider. Why isn't my internet working? So you convince them to do it, hopefully by running good experiments, getting information on how much it costs to interact with a consumer who's having a security incident, and the likelihood that a consumer who has an IoT security incident believes that part of the solution is changing ISPs. That's how I think.
So it needs to be like bundled into their modem.
Yeah, they need to have a local security provider that, the reason there is so much pushback for this is because it's very permissions based. There is a lot of blocking going on in that little box, right? And when your website is blocked, they will also call the provider. So the idea that a non-technical series of warnings that says, this is why we've given you this warning. There was just a paper on, a lot of this applies to AI also, because this really is explainable, a case of explainable AI, that it's blocked and you have to tell them why it's blocked. We can't say to them, well, we did feature extraction on this public key. It turns out that these 3 features should be aligned, and the certificate ID is not the same as it is copied, or, you know, like you're not going to explain features and fields to them. It has to be explainable, acceptable, usable, and timely. And if it's just blocking things, and if it blocks a thing and the standard warning comes up, they'll click through the warning. So why did Comcast bother to block it? Except for they're angry at Comcast now. I mean, I'm just using Comcast. Maybe I should say AT and Comcast. Comcast and T.
Any more questions?
I had a question following up on those machine learning models. What features do they tend to use to perform the classification? Like, what's relevant to determine what a rogue certificate is?
So what was relevant for us to determine a rogue certificate is we looked at okay, there are a lot of features, but there are basically 40 that we looked at. Date of issuance, date of first seen. So major companies have rollouts of certificates. They don't wait until their certificate expires and replaces a new one, right? So if we saw a certificate that was seen the first day it was issued, as that is not something the big 6 banks and Google and Microsoft and the big players do, right? But if it wasn't part of the big players, if it's like Gene's totally cool new website.com, having it observed the first time you see it is normal. So if it's in the top 100,000 and you see that indicator, that was one of the indicators. The other indicator of a rogue certificate is jurisdiction of the issuer and jurisdiction of the subject. So the Google rogue that we spotted during that early internship, which was very early in this whole project, was from a Indian transportation company. And we had only ever seen that issuer issue certificates for a very small set, right? So it was only ever issued in one small region in India. And then they're issued a certificate for California. The first issue they issued for California was Google. So it looked funny. They also issued one for Facebook. They were like, oh, suddenly, now that could happen. A small CA provider could suddenly decide to start issuing in other jurisdictions. We did not flag any of those. Because if you think about it, if you're going to start issuing in other jurisdictions, you probably are not going to have a large number of issuance all at once. Right? I mean, the first day Krispy Kreme opened in New York, it sold a lot of donuts, but the majority of donuts it still sold were in the South.
All right, great. Thank you all. Let's thank the speaker again. Thank you.
Have we